We'll now see the explanation for the given question. We'll now see the explanation for the program of the given question. As you see here, the first two if statements check if both the node values are present in the binary subtree. So if node.data is present, then the temp value is assigned to that particular node value. And if node.data is equal to n2 or n1, then that's also equal to the temp value. So what this means is we basically check if both the values are present. If one of them is not present, the one that is present will be returned as the lowest common ancestor. That is what is done using the first two if statements. And the second two recursions are responsible for traversing down to the last leaf node in the binary subtree and see if the node values are present. So if the node values are present, we return the address of the existing node value, and we'll only be returning only returning the root node with the value of the given node only when the left LCA value and the right LCA value are not null. This basically means that if both of them are not null, that node is the lowest common ancestor of the given two nodes. So that is what is given in the third if statement. And the last return statement means that if the left LCA value is not null, then we will be returning the left LCA value, and if the left LCA value is null, we'll be returning the right LCA value. We'll now take an example to find out the lowest common ancestor for nodes 14 and 20. The answer, as you know by now, would be node 8. We'll now see the algorithm and solve this above binary search tree and check if the answer is going to be 8. So the code as usual starts from the root node. The program as usual starts from the root node, and it checks if if the node.data is equal to either 14 or 20. Since it's not equal to both these nodes, we go to the left subtree, which is node 8. At node 8, we keep checking the two if conditions. We check if node.data is equal to either n1 or n2. Since it's not equal to both the nodes, we go to the left subtree of node 8, which is at node 10. At node 10, we again check if if the value at node 10 is equal to either 14 or 20. Since that's not the case, we go to the left subtree of node 10, which is node 17. At node 17, we check if node 17 is equal to 14 or 20. Since that's not the case, we again go to the left subtree of 17, which is null. We again come back. We again go to the right subtree of 17. That's also null. So we come back to node 17. So now at node 17, we check if the temp value is not null. It's not null, and since it's not null, we don't return the temp value. We also check the second if condition, that is left underscore LCA is not equal to null and right underscore LCA not equal to null. Since this condition is not satisfied, we also again don't return the node value. So we return the last return the value from the last condition, which checks if the LCA value from the left subtree is not null. Since that's not null, since that's null, we return the value from the right subtree, which is null. So at 17 returns null to node 10. So what this means is there is actually no node that's at there's actually no node at 17 or below the subtrees of 17 which has 14 or 20 in it. That is what this null represents. So now we come back to at 10. At node 10, we go to the right subtree of node 10, which is to node 14. At 14, we check if the value at node 14 is equal to either this this value or the 20th or the value 20. Since the first if condition is satisfied, v1 is 2 and the value of temp is equal to 14, which means the node that contains the value 14. Now we again go back to the left subtree of node 14, and which is null. We again come back. The same happens for the right subtree of node 14, which is also null, so we come back. So after coming back to node 14 again, we check if the temp value is not null. Since it's not null, we return this temp value, which is in this case 14. We return this temp, which is node 14, By returning temp, we don't actually return the number 14, but the node that contains the value 14. So we return the address of this node to the previous subtree. So again go back to node 10. After going back to node 10, the value of write LCA at node 10 is equal to value of write LCA at node 10 is equal to 14. So what this means is there's actually one value among these two values that's below the subtree 10, that's below the node 10. So that is what is mentioned in this write LCA. And again we check the two if conditions. In this if condition, temp is null and both the left LCA and right LCA values are not null, so we can't return this value. So we go to the final return statement, which states that if left LCA is not equal to null, we return a left LCA, or we will return the right LCA value. So since the left LCA is null for node 10, we return the right LCA value, which is 14. So root at 10 we return the value 14, or to be precise we return node 14 to it, and this is returned back to 8. So we go back to node 8. At node 8, left LCA becomes 14, and we go now to the right subtree of node 8. After going to the right subtree of node 8, which is 12, we check the first two if conditions. We see that it's not equal to either 14 or 20, so we go to node 20. At 20, we again check the same condition. We find out that the second if condition, that is if node dot data equal to n2, n2 is this node, is equal to this 20 value. Since that's satisfied, v2 is true for us, and we equate the value with temp. We assign temp to the value 20, or we assign temp to node 20. So we now go to the left and right subtree of node 20, which is also non-existent. So we again come back to 20, and we check if the temp value is not equal to null. Since the temp value is not equal to null, we return this temp value, or we return temp, that is node 20. We return temp, that is node 20, to the node that's above 20. So the control now goes back to 12. At node 12, value of left LCA is equal to 20, or it's equal to node 20. So we now go to the right subtree of node 12, which is node 22. At node 22, we check the two if conditions and see if they are satisfied. Since that's not satisfied, we go to the left subtree of 22, which is null. So we come up with a null value, and left LCA is null, and we go to the right subtree. So at 22, left LCA will be null, and at 22 we go to the right subtree, which is also null. Similarly, right LCA is also equal to null. Since both these conditions are null values and the temp is also null, what's going to be returned from 22 will be null. So null is returned back to 12. We again go back to 12. So at 12 we have the left LCA as left LCA left underscore LCA as 20, or node 20, and the right LCA is equal to null. So we check the next if condition, that is we check if the temp value at node 12 is not null. Since that's not null, we go to the second if condition that checks if both the left and right LCA values are not null. Since that's also not satisfied, we go to the final return statement, which states that yes, that we have to return left LCA if left LCA is not equal to null. So since left LCA is not equal to null, we return node 20, that is the value of left LCA. We return left LCA that is node 20 to node 8. So the control now goes back to node 8. So at node 8 we have left LCA as 14 and right LCA as 20. And we now check the second if condition, that is the value of temp. Since that's not null, we go to the next if condition, that is we check that if the left LCA and right LCA values are not null. Since that is not null, since both of these values are not null, we'll be returning the value of this node, we'll be returning the value of node 8. So what this basically means is we have one node which contains 14 and 20 below in its subtrees. That is, we have node 8 which contains the values 14 and 20 in its left and right subtrees respectively. This means that this will be the node 8 will be the lowest common ancestor of nodes 14 and 20, because 14 here is present below 8 and 20 here is also present below 8, and these values are the value of these nodes are returned to 8 you are using this recursion. And since the node 8 gets both these values, we come to this conclusion that it is node 8 that is the lowest common ancestor of 14 and 20. So this value will be returned to the value node 8 will be returned to its root node, which is to its parent node, which is node 9, and that goes, and the control goes back to node 9. So at node 9 we will have the value of left LCA as 8, and we again go to the right subtree of node 9, which is node 7, and at 7 we go to the left subtree of 7. Before going to the left subtree, we see that the first two if conditions aren't satisfied at node 7, so we go to the left subtree of node 7, and since that returns a null value, we go back to the control. So left LCA at node 7 is null, and same is the case for right LCA also. So right LCA is also not right LCA is also null. Since both these values are null, what's going to happen is we'll be returning a null value, because the next if conditions after the recursive statements will also not be satisfied, and what is left is only the null value that needs to be returned to node 9. So at node 9 the control again goes to node 9. So at node 9 we have right LCA as null and left LCA as 8. So we check the next if condition, that is the value of temp. Since that is not null, that is equal to null, we skip that particular if statement and go to the next if statement. That is also not satisfied, because one of the values, that is right LCA, is also null. So what is left is the last return statement, which states that if the left LCA value is not equal to null, we have to return the left LCA value, or we have to return the right LCA value. Since the left LCA value is not null, we will be returning this value, that is we will be returning node 8, return node 8. We will be returning this node 8 to the final. I will be returning this node 8 as the final output, and let the user know that 8 is the lowest common ancestor for 14 and 20. Thank you.